Hi, it's me, your guide on online tutorials from Silverstar Studios. Today we'll be looking at fractions and decimals, converting fractions to decimals. And this video, I'm making this video on request. So I hope you're gonna learn one or two things. So let's dig deep and see what we can learn today. Fractions are not real whole numbers. We have two types of fractions. We have the proper fractions and the improper fractions. So what is a proper fraction? A proper fraction is a fraction whose numerator is smaller in value than the denominator. Like you see here, it has smaller values as numerators than their denominators. Hence, when we convert proper fractions to decimals, they begin with 0 before the decimal point. Improper fractions are the exact opposite of proper fractions. Because their numerators have a bigger value than the denominator, when we convert them to decimals, they don't actually start with 0, they start with whole numbers before the decimal point. So we are going to take a look at examples of proper fractions. Yes, they start with whole numbers before the decimal point. So let's take a look at the examples of proper fractions. We have 1 over 2. Since the numerator is smaller than the denominator, it is a proper fraction. Other examples include 6 over 35, 8 over 200, 6 over 65, 4 over 28, 9 over 100, and so on. We are going to convert these examples here to decimals. So we are going to start with 1 over 2 and see its value in decimal notation. To convert fractions to decimals, we try to divide the numerator with the denominator, or by the denominator. And since the numerators are smaller than the denominator, it might not be easy to do this naturally. So there comes our 0 before our decimal point. So in the case of 1 over 2, is simply 1 divided by 2. Yes, 1. You divide 1 by 2. So since it's not possible, we'll write 0 and put a decimal point. Okay. So when we put our decimal point, we make the numerator a multiple of 10 by adding 0. So in the case of 1 over 2, we add 0 and divide by 2. So 10 divided by 2 will give us 5. Hence, we have that 1 over 2 is equal to 0.5. But this is a very simple case. We are going to take a look at more serious case and see how we are going to break it down. So let's take 6 over 35. So when you see fractions like this, first of all, you will try to see if you can break it down if the values are big. So we call it reducing it to the lowest common factor or multiples. So in the case of 6 over 35, we find out that 6 is not a multiple of 35. So we cannot go to breaking it down, since 6 cannot divide 35 without a remainder. Yes. In the second example, 6 is not a multiple of 35, since 6 cannot divide 35 without a remainder. Yeah. Okay. So what do we do in this case? We draw our division box. Write 0, put point, then make 6 a multiple of 10 by adding 0. So 35 into 60 will give us 1. So we subtract 35, the product of 35 and 1 from 60, and we will have 25. So 35 into 25 will not go, so we add 0, making it 250. Then we divide 250 by 35 and it gives us 7. 35 times 7 will give us 245. So we subtract 245 from 250 and we have 5. Yes. So we add 50 and we add 0 and divide by 35. 35 into 50 will give us 1. 35 times 1 is 35, so we subtract from 50 and we get 15. We add another 0 to 15 to make it 150 and try to divide again by 35. Into 150 we get 4. 35 times 4 will give us 140. And if we subtract, we have 10. So if you take a look at the breakdown here, you see that we can go on dividing and getting a lot of decimals. So depending on the value or number of decimal places required, we can go ahead and keep dividing. So to 4 decimal places, 6 over 35 is equal to 0.1714. Let's take a look at another example, 8 over 200. Like we said earlier, we first of all check if it is if we can break it down, since the denominator has a bigger value. So we reduce 8 over 200 to the smallest common factor or multiple. So to do this, we divide both the numerator and the denominator by a common number in which they will not have a remainder. So 8 we divide by 4, we have 2 over 50. We can still go ahead and divide by 2, and we have 2 into 2, 1 into 50 is 25. So we can now rewrite 8 over 200 as 1 over 25. Then we proceed to draw our division table, and yes, Let me mention that you can go ahead and divide 200 by 8 to get 25. So whichever way works out for you. If you are using a calculator, if you are not using a calculator, you can break it down gradually until you get the lowest common multiples. So we rewrite 8 over 200 as 1 over 25 and then draw our division table. So 25 into 10 cannot go, so we still write another 0 after the decimal point and add 0 to 10 and make it 100. So 25 into 100 will give us 4. 25 times 4 will give us 100. So we subtract and we have 0. So there's no need to go on dividing because we've already obtained the zeros as the difference. So let's take a look at the next example, 6 over 65. So the numerator is not a multiple of the denominator. So what we do is we proceed with our division table. So now I'll draw the division table. I'll draw the division table. 65 is outside, 6 is inside. We write 0. Since it cannot divide, we make it 600. 65 into 600 will give us 9. 65 times 9 will give us 585. When we subtract, we have 5, we have 1, and we add 0. 65 will now divide 150, and that will give us 2, that is 130. So 65 times 2 will give us 130. So we subtract and we have 20. We add another 0 and try to divide by 65. When we divide by 65, we have 3. 65 by 3 will give us 195. So we subtract, we have 5. We add 0. Since it cannot divide 50, we add another 0 and try to divide. And when we divide, we have 7. 65 times 7 that will give us 455. When we subtract, we have 5. We have 45. So we can keep dividing until we reach the desired decimal places. Hence, to 5 decimal places, 6 over 65 is equal to 0.09231. Since the next decimal place, which is 7, is greater than 5, we approximate the preceding decimal value or decimal place by a value of 1. Let's look at another example, 4 over 28. If you look at this example here, it is obvious that the numerator, which is 4, is a multiple of 28, the denominator. This you can see in 4 times 7, which is equal to 28. Hence, 4 over 28 can be rewritten as 1 over 7. So we draw our division box, write 0, put point, make 1 10, multiply and subtract. We have 4, which is minus 20, we have 2. You divide 20 by 7, you have 2, which is 14. We have 6. Add 0, which is 60. You divide, we have 8. 7 times 8 will give us 56. When you subtract, you have 4. You add 0 to make it 40. 7 into 40 will give us 5. 7 times 5 is 35. When you subtract, you have 5. Add another 0 and divide. You have 49. 7 times 7, which is 49. You have 1. So at this particular point, you see that there will be a recurring from the initial 10 we started dividing from. So in fact, the decimal places, the numbers will start to repeat themselves. So since we are not asked to stop at a specific decimal place, I will stop here, and we will have that 4 over 28 to 5 decimal places is equal to 0.14286. Well, don't forget to visit our YouTube channel and click subscribe if you like this video, and don't forget to send in your questions on the comment section of this video. Thank you for watching. See you in the next episode.